Okay, so let's get right into it. What if I told you there's a skill out there, a pretty valuable one, that you could start learning this weekend? We're talking about the ATtiny microcontroller. It's basically a tiny little computer chip that you can program to make your electronics do just about anything. And I'm not kidding about the value. $150 an hour. That's the kind of potential we're looking at. This isn't just a little hobby, it's a real deal skill that can open doors to building custom gadgets or even starting your own side hustle.
So, what's it going to cost you to get started with a skill like this? You might be surprised. It's less than 25 bucks. Yep, for less than the price of a pizza, you can get all the parts you need to start programming your own custom electronics. That is a crazy good return on your investment.
All right, so what is this thing we're talking about? A microcontroller? Well, just think of it like a tiny, dedicated computer on a single chip. It doesn't run Windows or anything like that. Instead, you give it a very simple set of instructions, just a few lines of code, and it'll do exactly what you tell it to, whether that's flashing lights, reading sensors, or spinning motors. It's the brain of the operation.
Okay, before we get to the really fun stuff, we do have to tackle a one-time setup process. Now, this is the part that honestly trips a lot of people up, but don't worry. We're going to walk through it together step by step. You do it once, and you never have to think about it again. The source material actually calls this part a little bit nasty, which is pretty funny and kind of true. But it's really just like a one-time puzzle. All we have to do is put a few files in exactly the right spot so our software knows how to talk to our little chip. So let's just knock it out.
Okay, you're going to want to follow these steps exactly. First, find your Arduino sketchbook folder. If you're not sure where it is, you can find the location in the software's preferences. Inside that folder, make a new folder. Call it Hardware. Now, open that folder and create another one inside it called ATtiny. You're almost there. Inside the ATtiny folder, make one last folder and name it AVR. Now, all you have to do is download the zip file from the Damel's GitHub, unzip it, and copy everything from inside it into that final AVR folder. That's it. That was the hard part.
And would you look at that? You survived the configuration. Seriously, pat yourself on the back because that was the biggest hurdle. Now we get to move from the computer screen to the real world and get our hands on the actual hardware. This is where it starts to get fun. All right, go ahead and grab your little ATtiny chip. See that little half-circle cutout on one end? That little notch is your guide. You want to line that notch up with the same notch shape you see on the programmer board socket. Now, the pins on the chip might be a little too wide, so just gently press one side against a flat table to bend them inward just a tiny bit. Then, line it up and push it firmly into the socket. You should feel it click right into place. And now, for the magic, it's time to write the instructions, the code that tells the ATtiny what to do. For our very first project, we're going to do the classic hello world of the electronics world. We're going to make a light blink.
Okay, here it is. This is the entire program. Now, I know it might look a little intimidating if you've never coded, but trust me, it's really simple. See that section called loop? Everything inside there just runs over and over again, forever. It turns a pin on, it waits for half a second, it turns the pin off, waits again, and then repeats. That's the whole secret to a blinking light.
So that very first part of the code is the setup. We're just telling one of the little metal legs on the chip, hey you're going to be an output. That just means it's going to be sending a signal out instead of listening for one in.
This line, digital write high, is where the action happens. This is the command that tells that pin we set up, okay, send out some electricity. It's basically the same as flipping a light switch to the on position.
Now, if we turned the light on and then immediately turned it off, it would happen so fast we'd never even see it. So that's where this next line comes in. Delay 500. It literally tells the chip to just pause and do nothing for 500 milliseconds, which is half a second. This gives us time to actually see the LED light up. And as you can probably guess, digital write low does the exact opposite. It cuts the power to that pin, turning the LED off. Then we have another half-second delay so we can see that it's off. And since all of this is inside that loop we talked about, the whole thing just starts over, giving us that nice steady blink. So we've configured the software, we've wired up the hardware, and we've written the code. There is only one thing left to do. We have to send our program from the computer over to the tiny brain on the chip. This is the moment of truth.
Okay, last check before we hit the big button. In your Arduino software, go up to the Tools menu. Just make sure the board is set to ATtiny 85, the programmer is set to USB Tiny ISP,
and the clock is set to internal 1 megahertz. Once those 3 things are correct, go ahead and click that upload button.
The software is going to do its thing. It's compiling, uploading, and success! Look at that, a blinking light. I know it seems like a simple thing, but that little flash proves that everything, the software setup, the hardware connection, the code, it's all working perfectly. You have officially programmed a microcontroller from scratch. So you see, you haven't just followed a tutorial here. You've actually learned the entire fundamental process. You now have the power to tell this little chip what to do. And the real fun, the real learning, starts right now when you start to experiment. So I'm going to leave you with a little challenge. Go back into that code, find those delay 500 lines, and just change the number. See what happens. Can you make it blink faster? Slower? Can you make it flash like a heartbeat? The foundation is all here. The only question left is, what are you going to build with it?